So, in this video, I'm going to talk about a few things. I'm going to talk about like missing data, bad data, how to replace it, and also how to convert the type of a column, right? And types of columns, which I'll get into. But first of all, I need to show you something. I have actually made a new Excel file, this scores2 file. And we're going to read in, instead of using pd.read CSV, we're actually going to read in this Excel file. It's got a few extra entries that aren't so correct. And we've also used a new import numpy as MP. I'm not going to go over how numpy works. We're just going to use it for a data type in this tutorial. Right. With that being said, let's read in our import and let's read in our data frame. Right. Now, I'm going to show you the data frame, just show you what's kind of there, what's kind of different and whatever. And you're going to see that here, where we get to, index 18, the age, instead of being a number, is now DE, right? And here on this line, or on this row, should I say, we've got two NaN values. Here on this row, we've got two NaN values. Here on this row, we've got two NaN values. And here for the name, we've got two unknown values. What NaN is it's actually a NumPy data type called NaN, which means not a number. So if we actually look at our scores2 Excel file, which just came up, it came up outside of here, so I can't really show you it. But basically, these NaNs are actually just missing. They're just missing values, essentially, right? So yeah, we can't see them. They're missing values, things that we've forgotten to put or whatever. That's what they actually are in the sheet itself. Okay, and we probably want to replace these values, get rid of these values. This value, this DE value, for example, it's not a number, and we want it to become a number. We want this NaN to be converted to a number or to be read like one, because you might not know this, but this whole row is actually classed as a string or an object. That's the data type as this row, but we'll get into that a little bit later on. For now, let's get to how we'd get rid of these NaNs, right? So there's a pretty simple way to get rid of these NaNs. We can get the data frame and we can use the drop NA function. And this will simply get rid of all the NaNs. Well, it won't, because we need an in-place equals true argument. But I'll just show you what that'll look like. You can see that those three, is it 3 rows? Yeah, these 3 rows, any of them that have an NaN in them will just be destroyed in the return data frame. But this doesn't actually change the original data frame. It just returns a data frame with all those NaNs dropped, right? If we actually look at the data frame again, you'll see that it hasn't changed, okay? We can use the in-place argument, but first of all, I want to show you basically how this works. So drop NA has a couple of default arguments. The first is axis, which is normally equal to index, which means that it's not actually, it's going to drop indexes, right? And we've got a how argument, which is any, right? So we're saying any of these indexes that has an NaN value, i.e. 19, 20, and 21, drop them, drop the index, right? And you can see here where it had been dropped. And if we run this, we'll get the exact same thing we got before. Cool, 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 cool. You can see those indexes have all been dropped because they contain any NaN, right? Now, there's another way we can do this. We can do sc_df.dropNar, i.e. drop NA. And we can say the axis is still equal to index. No change in that. And we can say how is equal to all, right? And let's just see what this does. And then I'll go over and explain it, yeah? So you can see all of these are still relevant. They're still here. And the reason for that is basically the how argument tells you what you'll drop, so how you'll drop them. This anyhow means that it'll drop any index that has at least one NaN value. This all means that it will only drop indexes that have full NaN values. So if every item in the index has the value of NaN, then it'll drop it. Otherwise, it won't. As you can see, none of these have all values of NaN, so not a single index/row has been dropped, right? So probably not what we want. Now let's get into columns, okay? So we can actually drop entire columns if there's an NaN value there. But if we do this, so we'll say axis equals columns, and we'll say how is equal to any. What we should get, hopefully, is nothing. We get nothing. We get an empty data frame. So why have we got an empty data frame and a bunch of indexes? Well, what's happened is this now drops each column that has any NaNs in it. Now, every single column here, the first column, the age, has got an NaN in it. The name column has got an NaN in it. This column's got an NaN in it, and the other column's got an NaN in it. So it drops all of the columns, i.e. the entire data frame, and so the data frame becomes an empty data frame with all these indexes, right? Now, we can once again use the axis equals columns argument, and we can say how equals all. So it'll only drop a column where every single value is NaN for that column, right? And what do you know? It doesn't change because none of these columns have the value NaN in every single row or every single index, so it can't drop them, right? Now, going back to our actual data frame, you can see there's been no changes, which is kind of unfortunate for us because maybe we want to get rid of all these rows with NaN. So what we're going to do is we are going to get rid of those rows with NaN. We're going to say drop nar, and we're going to say axis equals index. We're going to say how equals any. And we're going to say in place equals true. Right? You've probably seen that before. I'm going to say sc underscore df afterwards. And we're going to run basically all of this just to check that this has got rid of all the items. And you can see our actual data frame now no longer contains those NaN values, unfortunately, or those rows with NaN values. I don't really want that, to be honest. I actually want to deal with them later on, so I'm actually going to reload the CSV, the Excel file, should I say. So I'm going to reread it here, and that should be fine. Let's just check it. Let's check that it looks more or less correct. Yep, that looks fine to me. Now, there's a few other things you can see here, i.e. the unknown values, and you might look at them and think, well, I don't know the names of these people, but I don't want the value to just be unknown. Maybe I want it to be something else. And we could actually replace those unknown values if we want. So we can say we want the data frame. We're going to use the .replace method. And what this does is it'll replace every instance in the data frame of a certain value. And we want to replace unknown. I don't know, what should we replace it by? We could replace it with missing. And we want in place to be equal to true. We'll put sc underscore data frame so we can see our data frame afterwards. And basically it should change these two values to missing now. Right? So we've changed those two values to missing. What else could we possibly change? Well, we could undo that change entirely if we wanted to. and we could replace unknown values, or missing values, should I say, because they're now missing values, with np.nan, which has come from this np here, this numpy thing here. We'll say in place equals true. Right. C underscore df, and you'll see that these two missing values will now become nan values. Right, there we are, nan values for you. Now, we can also find out, so let's say we've got a massive data frame with 500,000 different rows, right? And we want to just get all of the rows that have NANs, right? Well, we can find that just by simply using our data frame and using the isNar function on it. And we'll get all these NANs. And you can see here, these last two, it's true, true, and it tells you where you've got np.nan values, right? And nan just means not a number, okay? Now, you can actually fill all of these NANs with a random value. So what these NANs are, what are they? Well, they're actually missing or unknown values, right? So we could probably do to fill this in with, I don't know, the word missing or the word unknown. So in our data frame, we can use on our data frame a function called fillNar, and this will actually fill our NAN values with a different value. We can say that we want the values to simply just be missing, right? Little problem with that is it looks really good here, but the actual data frame hasn't been changed at all. So what argument do we need? You've probably guessed it by now. We're going to have to add the argument in place equals true, right? So I'll just put that here. Do that. And then when we look at the data frame, you can see that those are now missing values. Now, one more thing that we might want to do is we might want to change kind of these values to something else, right? Or we might want to change the data types in our little data frame, right? We might want to see what the data types are, okay? So I'm going to go on df.dtypes here. Sorry, this data frame .dtypes, okay? And we're going to have a little look. Oh, series object is not callable. Oh, that's why. Sorry. Data types is not a function. It's actually an attribute. So I don't know what happened there. And these are all classed as objects. Now, this is because I'm using the scores2 one. And basically, score before was actually float64, but it's now become an object because basically what an object means is that either the data types in the columns are mixed, so here we've got a mixture of numbers and these are strings, or they're just strings. So in all the other cases, they're all just strings, right? I'll explain that by actually importing the original CSV file. So we'll say that that is equal to read underscore CSV. What's it called again? Scores.csv. Let me just put that like that. 1, 2, 3. There we go. Oh, it needs to be pd.read CSV. Right, and now let's have a look at this data frame's data types. And we should actually get a float64. So we've actually got an int64 for score. That's because when you actually look at the scores CSV, in fact, we'll look at the actual data frame. Okay, we'll look at the data frame and you'll be able to see why score is an int. because on the original one, every single value is an int. But if you look at age, all of age should probably be an int as well. But the problem is this DE here is actually a string. So age's data type as an entire column defaults to object, and we want that to be int, really. All we need to do to change that is either change this into NaN and convert this all to float, which we're not going to do, or we can change this one value here into something that can be converted into an int, and then we want to convert all of these into int. Okay, so I'll show you how to do that. So we're going to get, first of all, that dot loc. Where is it? It's 18, so we're going to get the 18th index, and we want to get the age column, and we're going to say that that is now equal to, and we're going to say that Oscar is 35. Now, in the real world, you'd want to check what his age is, or you might want to get the mean of all these ages, right? And then put that as the default age, or turn it to NaN. For this one, I'm just going to simply put the age as 35, okay? We're going to have a look at the df afterwards, right? And we can see all these ages. Now, has that changed the data type? Let's have a look. Let's have a look what happened. Oh, dtypes, sorry. Dtypes is the attribute. And you can see it's still an object, and that's because it loaded in as an object. It's of type object because it was mixed ints and a string, right? So even though these should all be integers, it's still put as an object, even though these are all, convertible to integers. So what we're going to have to do is we're going to have to say recast the type. So we're going to say sc_df age, okay, because we're going to change that whole column, is equal to sc_df age, right, dot as type int. I'm actually going to change the type there. We'll have a little look to see if this works, or if it hasn't worked. So we'll try and change it there. No errors, so it's probably worked. And now when we look at that, we've got an int 32 rather than 64, but it is now an integer, so these can be counted as integers. And we can actually do all kinds of stuff on this. So we can say scdf age dot mean, right? You can get the mean age there. We wouldn't have been able to get the mean age before because we wouldn't have been able to convert all of the items into integers because one was a string. So it would have been impossible to get the mean before and to do mathematics with any of the individual items in the age column, right? Anyway, that's pretty much it. There's all kinds of other conversion and ways of handling bad data and missing data that you could find out about pandas, but I just covered the basics here. Thank you for watching and hope you enjoyed.